No, I'm not.
I just over to you.
Oh, I didn't hear you at all.
I did.
Oh, okay. Seems like I wasn't able to hear what was going on. So today I'll be talking about Title 24, 2016, and there is a 2019 version in the works, but well, it's not out yet. So as soon as it comes out and we can fit it into the schedule of our webinars, we'll prepare something for that as well. Title 24 is pretty much restricted to California, so it's pretty much meeting the requirements there, but we can see that like I've seen specs coming out of like Arizona and neighboring states that have signs of, or were either designed by engineers in California or have signs that they have borrowed some stuff from Title 24. So it's a good thing to know what's going on with Title 24. And, you know, there are a couple of important topics that are a bit different from Title 24 to IECC 2015 or 18 and ASHRAE codes that are used in other states. One of the important ones is the criteria for partial on as per Title 24. So all the other codes, their definition of partial on is that the sensors should turn the lights on to maximum 50% of the load. But as per Title 24, partial on means 50 to 70% of the load. So there's a bit of a difference. Obviously, the definition and criteria for a daylight responsive control is different in Title 24. Quite a sunny state, unlike us here in Minnesota, that we have a lot of gray skies. They get a lot of sunlight, so they can save a lot of energy by dimming down the lights when the sun is out there. In Title 24, half of the receptacles in most areas need to be controlled based on occupancy. That's something that is not very common in all country. And the most important of them all is automatic demand response control. That basically impacts a huge segment of the industry because many buildings fall into that category and need to have a system that can meet code requirements for automatic demand response. And then we're going to talk about, and Title 24 talks more about guest room control compared to other codes that they really don't seem to care that much about guest rooms. I don't know the reason. They have it as like an optional thing, but it's not really, you know, in depth and in detail. We are gonna first review the segments of the code and the requirements, and then based on every, then we're gonna go over some design applications and you know, get into more details in those places. The basic requirement, like all the other codes, that you need to have a local manual switch within the area to control the lights and turn them on and off. The next requirement that is a bit different from other codes is that multi-level control is used across the board in Title 24, and pretty much in all areas you need to have some form of multi-level control. And nowadays, with the use of LED fixtures, that would be 0 to 10 volt, well, as per the code, 10 to 100% continuous dimming, which means you need to have some sort of 0 to 10 volt dimming on your sensor or in your control method. The sensor shutoff and shutoff is about how you need to have some time or occupancy based system to turn the lights off in each area. And in our case, we are talking mostly about sensor shutoff and how it should work and where like what kind of sensor we have to use. And then there are some exceptions that they don't require the full shut off of the lights, and they require partial off that we get to in the next slides. One of the most important requirements is the definition of daylight zones and what are the requirements, what are the criteria for it, and then we'll get to the example for that, and there I will go into more detail. Daylight zones, as I've told in the previous webinars, it's quite a misunderstood topic. People tend to over-design quite a bit to meet daylight zone and daylight responsive control in general, but I hope we can help you get a better understanding of it. As I said, demand response control is a very important and big requirement in Title 24, and we should, as you can see, it applies to buildings larger than 10,000 square feet and with lighting power density of more than 0.5 watts per square feet. We'll go into detail later about that. And the last item on our code requirement checklist is receptacle control. 50% of receptacles are required to automatically turn off based on occupancy or after a vacancy of 20 minutes or less. And if you look at the text of the code, there are a lot of places, as you can see also in my previous table, there are a lot of places that it refers to table 130.1-5. It's a table that basically explains all the lists all the different fixture types and how they should accomplish multi-level lighting control and uniformity requirements in those with those fixture types. The one that applies to pretty much all the fixtures we use these days is LED luminaires and LED source systems, which are required to provide continuous dimming between 10 to 100%, which is easily complied with by having a 0 to 10 volt sensor or dimmer, depending on the application and the situation we're talking about. So now we are gonna, I'm gonna go over each area. Mostly these are mostly office areas, and explain what are the code requirements for each of them and how we can comply with those requirements using Steinel. What is our best solution or our recommended solution to meet the code requirements for those. So the smallest part of the code, or the smallest part that is mentioned in the code, is small private offices smaller than 250 square feet. Obviously, you need a momentary switch or a slide dimmer to comply with the requirement of manual control. Multi-level control is required, whether it's through the sensor or the or a slide dimmer. Well, as I mentioned, we're using occupancy sensors to shut off the light, so that part of the code is, obviously covered. And then we need to have a receptacle control system. So there are two ways to achieve this as per our recommendation. So as you can see, these are the two methods we have. I will start with the layout on the left, and then I'll go to the one on the right. So as you can see, there is a small office here. There's a ceiling fan that pretty much prohibits use of any kind of sensor with ultrasonic technology, which means ultrasonic and dual tech sensors are out for this application. And since we want to avoid the sensor looking out the door, the best sensor type that we should use would be a PIR corner mount sensor. In this case, it's the IRCM COM2-24. Now, why COM2-24? Because our COM2 sensors have two outputs, one for lighting and one can be used for a receptacle control. So you get two separate time settings, time delay settings. So you can set your lighting to a certain timing and your receptacle control to a different timing. Lighting would be manual on, receptacle control is auto on. So that's how that goes. So you need one sensor for such a small office. You need two power packs, one for lighting and one for receptacle control. And then on the wall for your manual override, you need a 0 to 10 volt slide dimmer to control the lighting, to achieve multi-level lighting control. These offices may have windows and you can define a daylight control zone, but as we will talk more in detail in the next slides, they won't meet the requirement, they won't qualify for the requirement to have daylight responsive control. So we don't have to worry about that, and this solution meets the code requirements completely. The other solution that you can see on the right-hand side is using corner mount DIMM-24 PIR sensor. And then here's where I'm going to introduce our latest product, which will be available in Q1 of 2019, our TR200 and TR250 power packs. Now, the main difference, at least for this application, between a TR200 and a TR100 power pack is that our TR200 power packs have a built-in timer that helps us adjust the time settings on the power pack, and the sensor is just providing the occupancy vacancy signal to us. Well, in better words, it's occupancy and lack of occupancy, because it doesn't send anything when there is no occupancy. So you need a IRCM DIMM-24 sensor, a TR200 power pack for the receptacle control, and with its built-in timer settings, a TR100 power pack, or another TR200 power pack to control the lighting, and then you can use a 0 to 10, LV1W momentary switch. So the next area that we're going to discuss, and it's again quite common and is available in all, you will run into it in all projects, is public restrooms. The public restrooms have a much easier code requirements. Again, you need a manual override control, you need multi-level lighting control, and you need to have a sensor to turn off the lights. Now, one of the good features, like the sensor that we recommend for public restroom, is US Quattro DIMM-24, which is an ultrasonic sensor with dimming function built in. One of the nice features in this sensor is that you can set it to the dim before off function. So dim before off function, what it does is after your main time occupancy timer expires, dims down the lights to a predefined value, which can be from 20 to 50%. So the lights don't completely go off, and then they stay on at that lower dim level for another 15 or whatever setting you put minutes, and then they go off. So, you know, if someone opens the door, the lights won't be completely off, or if someone just walks in, the lights won't be completely off in that meantime. Just to remember some a little thing is that the total time delay for the two timers, the occupancy and the dim before off timer, is 30 minutes. So you can't set both of them to 30 minutes and expect the lights to stay on for for 1 hour. And as you can see here in this little men's restroom that I've shown here, we really need just one ultrasonic US Quattro DIM-24 sensor, TR100 power pack, and momentary switch to control the lights. Now you may run into an application that they need the exhaust fan to be controlled by true occupancy as well. And that's where, again, our TR200 power packs with their built-in timer come in handy, that you can put another power pack in there and set it up so it will turn on and off the exhaust fan based on the occupancy. Next area which we're going to talk about is corridors and stairwells. Here the code looks very much like a public restroom, with one difference. Stairwells and corridors, especially the corridors that lead to points of egress, must be only turned partially off. So the lights won't be turned off completely at all. So you still need your manual override switch, which in these cases, they should be blocked from unauthorized access. You have your dimming function, and the dimming sensor should be set to partial off. So there would always be some lighting in the areas of egress and, you know, for safety reasons. I've shown here a stairwell, and I didn't show my usual solution of, you know, hallway. So for hallways and stairwells, we have two very nice sensors, US one-way DIM-24 and US hallway DIM-24. Very good ultrasonic sensors, very good reach. They provide you with very good coverage. And as you can see, you have a sensor, you have a power pack, and a momentary switch. Now in a corridor, you have to do the design based on the length of the corridor. So you may need multiple sensors and multiple power packs, and you would have multiple zones. So the concept is the same. You just have to add more sensors and power packs based on the that specific project. Now things are starting to get interesting, because these are the places that things can get tricky easily. So what part of the code applies, what part of the code doesn't apply. So I specifically have mentioned internal office areas, which is the open office areas or larger office spaces, like conference rooms and such, that usually don't have access to the daylight. They are not by the windows. So the daylight responsive control requirements don't apply to them. Now let's have a look at what applies to these areas and what doesn't. They pretty much fall into the same category as small private offices. So you need a manual override switch, you have multi-level dimming, you need to have an occupancy sensor of some sort, and you need to have receptacle control. Now, if we look at our first solution here. This is a conference room, and here I've put 2 DT Quattro DIM-24 sensors, and to provide proper coverage. As you can see, we have the linear track in the middle, and then we have the 8 fixtures on the side, on each side. So we need to have 2 lighting power packs, and of course we need a power pack for receptacle control. Same as our previous solution, you have to have you have the TR200 power pack for receptacle control, and TR100 power packs for lighting control. And then you have a 2-button momentary switch to provide manual control. What I forgot to mention in the previous section was that, I mean, if you want to reduce the number of SKUs in your bill of material, you can always put TR200 everywhere, and it will work just fine. But if you want to, you know, value engineer the project and you know, optimize the project, you can obviously go with TR100 power packs in this case for lighting, and TR200 for receptacle control. We can do the same conference room in a different way. Again, you have seen this same solution before as well. Now here we are using 2 DT Quattro COM 2-24s, 3 TR100 power packs, and 2 0 to 10 volt slide dimmers. So the dimming is achieved through the 0 to 10 volt slide dimmer, and then lighting and receptacle control are achieved through the 3 power packs that we have. Now we can look at this case a little bit differently, and that is, what if this was a conference room by the window? So let's say the top part of the glass, the top part of the conference room had windows. Again, I can't say for sure, but unless, I'm guessing, unless the windows are from floor to the ceiling, we wouldn't need daylight responsive control for this, because probably only those 4 fixtures at the top of the slide would be in your daylighting zone, and I'm guessing they are not more than 20 watts each, so 4 of them is about 80 watts, which doesn't qualify for this daylight responsive control anyway. So that's why I dedicated the whole segment to that application. Now we get to the most important segment of this webinar, which is the open office areas and lobby. This is the place that you probably will have to provide some sort of daylight responsive control, because you, as you can see in this photo, you probably have very high ceilings, so your daylighting zone would be very big, and then you have wide and big areas that have a lot of fixtures in them, and the requirement, the load requirement for Titan 24 is actually 120 watts in or partially in the primary daylighting zone. So if you look at here, again, this is an example. It's not necessarily accurate or representing an exact case, but I've taken the layout from one of our projects in California, so we can do it to some extent. So as you can see, we have primary daylight zone, we have secondary daylight zone, and then we have the general lighting zone. I have kind of assumed that we have those track lights that you can see there. I've assumed that the primary daylight zone is big enough that there is about 120 watts of those lights load in the primary daylighting zone. So we need to have some sort of daylight responsive control in there. And then you have the secondary daylight zone, and then you have the general lighting zone. Now, you may wonder why IR Quattro HD DIMM-24 is used here and not a dual tech or an ultrasonic, because this is an open office area. It's very likely that we would have partitions there that would block the PIR sensor. That is true, but I mean, for the sake of this webinar, I assume that it's a complete open plan office. The reason I didn't use any dual tech or ultrasonic sensors, as you can see, are those ceiling fans that will cause trouble. Your sensor won't be able to shut off the lights if those fans are moving, if you use an ultrasonic or a dual tech sensor. Now, here, because since I've assumed that there are no partitions, so I can use my sensor with biggest range. So you would put, based on the size of the room and coverage requirement and all that, I've put 2 sensors in the primary daylight zone, 2 in the secondary daylight zone, and at least 4 in the general lighting zone. You would need a power pack to control the lights in the primary. You need a separate power pack to control the lights in the secondary daylight zone, a power pack, at least one power pack for general lighting zone, and one power pack, again, at least one power pack for receptacle control. Obviously, I've made a big assumption here, especially with the receptacle control, that such a big open office area, half of the receptacles are all on one circuit from the distribution board. This is probably not true, but again, for the sake of this webinar, let's just assume it is. So for such a big space, you would need probably 6 IR Quattro HD DIMM-24s, 4 TR100 power packs, and a 3-button momentary switch to control each zone. Obviously, if you have more zones and all that, I mean, we have to study it completely to be able to make the final decision on such a big open office area. So this is how we set our sensors in general, and especially for these applications like daylight responsive controls. As you can see, the app is available on any smart phone that you have, and then you have to use our smart remote to communicate with the sensor. So you can easily, as you can see, set your light level, operating mode, photo control option. The parts you can see are the normal time delay, etc., etc. And you just press send, and you're good to go. And you can quickly and easily program a lot of sensors in a matter of minutes or hours. The next topic that we're going to discuss would be warehouse control requirements as per Title 24. Now, my guess is most warehouses are going to be larger than 10,000 square feet, so they would require the automatic demand response control. So we can't just use fixture mount high bay sensors to meet the code requirements. But we have worked on a partnership with another company, and our sensors our new sensors are wireless ready. So for those requirements for warehouses, you can always contact our regional manager, our trainer, to get you the right solution about warehouses. But as you can see here, we have this partnership that allows us to use an addressable wireless network lighting control using our high bay sensors. And as you can see, we have the LC1 lens cover to limit the coverage of our HBS 200s to within each aisle as per the code requires. So overall, it's a good, nice solution. It's wireless and you know, helps us still play a part in projects that we won't have a good answer as a standalone system. I mean, no one has, to be fair. The next topic that we're going to discuss is something that I've brought up from the beginning as the most important topic in Title 24, which is automated demand response control. So I did a little bit of a study in demand response control, and it goes back to sometime around 2002, I believe, that California had some energy supply issues, and they came up with this plan to automatically reduce the power consumption of the users during peak hours to be able to supply, to have enough supply to provide energy to everyone. So this is what the requirement is, and this is how we can tackle it using our sensors. So the requirement is quite simple. It's a very nice number, 10,000 square feet. Any building larger than 10,000 square feet needs to have a system that can respond to an automated demand response signal sent on a standard protocol, and reduce the lighting power by at least 15% by dimming the fixtures uniformly. So this seems, as you can see on the graph that I have put on this page, your actual demand would be the red line on the top, and then where that blue signal happens, you see that the demand falls down to that dark gray dotted line at the bottom. So that's a significant drop if you think about it, for several hours that you're using less energy, and you know, make sure that no one is suffering a blackout or disconnection. So how Steinel, so far we never talked about any network solution in our range of work, and I know we are working on some stuff, but the details and when they will be available are not clear to me. So I won't go into that topic. However, we've partnered. The good thing about our sensors is they are very easily integratable with other systems. So you can have the best of both worlds. You can have a high quality sensor with you know, a good coverage and a lot of features and you know, reliability, pair it with a good third-party system and meet all the code requirements, and not just be limited to only projects that are 10,000 square feet or less. And then you go to the last topic, which is one of my personal favorites: energy saving in hotel guest rooms. So Title 24 talks quite a bit about how a guest room management system should increase energy saving in hotel guest rooms. And the image you see is one of my favorite hotels that I worked quite a lot for many years on it. Yas Viceroy in Abu Dhabi, overlooking this marina here, and the other side is overlooking an F1 circuit. So what you can do and what the code requires for energy saving in hotel guest room is the use of a key card holder and the combination of a magnetic door contact and occupancy sensors. The logic can get quite complicated, but, well, we all have to rise up to the challenge and, you know, prepare something that can meet the code requirements and, you know, save energy. In hotels, this occupancy and vacancy sensing doesn't only affect lighting, it also affects HVAC systems as well, that not only you're turning the lights off, you are adjusting the set point on the thermostat depending on the season and the temperature outside or inside the room. You're either reducing or increasing the set point of the thermostat based on occupancy or vacancy. Another way to do it is, or at least another way to even improve further on this, is using a set point adjustment through integration with the property management system, PMS. That when you check in, the set point in the room that is allocated to you is adjusted. And once you check out, regardless of what you have done or anything, the lights and the set point of the thermostat can be adjusted again to a vacant mode. So a lot of interesting stuff in Title 24, and feel free to contact us through our phone lines or email with any questions you have about Title 24 or any other topic in lighting control systems that you think we can help you with. If you want us to help you with a layout or something, again, send it to tech@steinel.net, and we will try to prepare something and get it back to you as soon as possible.
Okay, so we'll go ahead and open up the phone lines. If anybody has any question, go ahead and start asking. Everything should be open. I didn't get any questions via email. So if no one has any questions on the phone, we can go ahead and conclude this webinar. Thank you so much for attending. We will have this posted online for anyone who missed it by tomorrow or the next day. Okay? Thank you so much for attending.
Thank you, everyone.